This program is a co-production of Access Alberta and the Southern Alberta Institute of Technology. Gang forming can be defined as the grouping of individual forms into a large unit that is moved to new locations by cranes. Gang forming is most cost-effective where there are large areas of similar type construction to be built. Gang forming of walls is particularly efficient. The term gang form is used because panels are ganged together to form a single, reusable form. For custom jobs, loose forming is still used. Where the structure is unusual, loose forming is the only viable option. However, loose forming requires extensive dismantling and reassembly of the forms, and is not nearly as cost-effective as gang forming. Gang forming of this haunch would not be appropriate. Gang forms are constructed on the building site to suit the job requirement. The major components of a gang form are the form sheathing, typically made from plywood. The sheathing contains the concrete and determines its final shape. Top quality plywood is used so that the form will stand up to repeated and heavy use. The studs provide the vertical support and strengthening for the form sheathing. Wailers are run horizontally behind the studs. In this case, they could also be called strongbacks. Ties are used to hold both sides of the form together and to resist the very high pressure of the concrete. Ties also determine the thickness of the wall required. Gang forming has been developed to save labor on the job site. Therefore, ties are designed to be strong and few in number. This is a taper tie and can be passed through two form surfaces from one side. This she-bolt assembly has two female tapered ends and a threaded male insert. For varying wall thicknesses, extra sections of threaded rod can be coupled to extend the overall length. A special threaded nut called a tilt lock has been designed for quick release to save time on the job. The tilt lock is obviously much faster than the traditional nut washer assembly. A wide variety of coil ties is available. The name coil tie comes from the spring construction. It receives a very coarse thread bolt. Removable plastic cones are threaded over the end of the coil, leaving the coil inside the concrete wall for possible reattachment. The strength of the tie is related to the gauge of rod used to join the two coils. Coil rod can be used instead of a bolt. Use of a speed nut makes removal of the tie much quicker. The coil rod and speed nut can replace a standard bolt. One of the features of this coil tie is that you can include a filler rod to vary the length of the tie. This is necessary when building tapered walls. This particular tie has an added feature, built-in water stops. These water stops assist in preventing water from seeping through the concrete. This is important in buildings such as this sewage treatment facility. The greatest advantage of the coil tie is its adaptability for reattachment of additional formwork once the original formwork is removed. All formwork requires bracing. Gang forming requires especially strong bracing. Now that we've studied the parts of a typical gang form, we can consider the pressures put upon the formwork by concrete placement. Fluid or plastic concrete exerts a great deal of pressure on the formwork. This pressure is exerted in much the same way that water causes pressure on a dam. Notice the pressure is greater at the bottom of the dam. As with all fluids, pressure is defined as depth multiplied by the unit weight of the fluid. However, concrete is not a true fluid. It is only a fluid for a short period of time. As concrete hardens, it changes from a fluid to a solid mass, and the pressure decreases. The major factors affecting lateral pressure on the formwork are as follows. Rate of placement. The rate in meters per hour at which fresh concrete rises within the form. Temperature of the concrete. In warm conditions, heat will speed up the hydration process. Heat therefore decreases the time during which pressure is exerted on the formwork. Conversely, low temperatures slow down the hydration process and pressure is exerted for a longer period of time. Vibration consolidates the mix and allows entrapped air to escape. Vibration actually increases the pressure on the formwork because concrete particles are forced into motion. All pressure charts and formulae allow for normal vibration. However, excessive vibration allows the heavier aggregate to sink to the bottom of the form, thereby weakening the concrete. Unit weight of the concrete. As with all fluids, pressure is a result of the depth multiplied by the unit weight. The density of the aggregate will determine the unit weight of the concrete, and therefore affects the pressure on the formwork. Type of cement. Different admixtures are often used, which alter the physical properties of the concrete. For example, if a retarder is used, this will slow the initial rate of hardening and cause the pressure to be exerted for a longer time. Consistency of mix. A low slump mix is relatively dry, therefore reduced pressures can be assumed. On the other hand, a high slump mix acts more like a true liquid and produces higher pressures. This model illustrates the effect of pressure on the formwork. The plywood is the principal support for the fluid concrete. The amount of deflection is dependent upon the strength of the plywood and the distance between the supports for the plywood. The next support components affected by pressure are the studs. Stud deflection is dependent upon the strength of the studs and the distance between support for the studs. Since whalers support the studs, pressure also causes deflection of the whalers. Size of whalers and tie spacing are the major factors here. Tie bearing plates must be large enough to prevent crushing. Once the formwork is removed, The bulging or pillowing can be noticed. For architectural walls, excessive pillowing is not acceptable. The overall strength of the formwork depends on the ties. It is important to note that one tie supports all the formwork indicated here. The sequence of activities in gang forming begins with placing the first side into position. The form has been cleaned and oiled since it was last used. The lower end of the brace must be firmly attached to a solid anchoring point. After the first side is securely braced, layout and installation of any openings takes place. Once all doorways and miscellaneous sleeves have been set, the rebar can be tied in place. Some bulkheads must be installed after the rebar is in position. Notice that dimension lumber is used because it is easier to strip out than plywood. Although carpenters are the main tradesmen involved, other trades, such as electricians and plumbers, usually set their own inserts or services. Cooperation among all the trades involved is essential to the smooth flow of work. Once all inserts are installed, the second side can be closed up. Once the top yokes have been secured, the crane cables are released and the ties can be inserted through both sides of the formwork. After all ties have been secured and corners locked in, the wall forms are aligned and plumbed, ready to receive the concrete. Gang forming is an efficient system for reusing large-scale concrete formwork. Experience on job sites suggests a number of practical tips. Forms should be cleaned immediately after use. Excess concrete should be removed before forms are flown. Falling lumps of concrete would be most dangerous. Because of heavy and repetitive use, gang forms must be solidly built, with special concern for reinforcement of edges. Efficiency is enhanced when ties and hardware travel with the form. Because forms are handled by cranes, they must be sturdily built. Yet another reason why gang forms must be a very strong construction is that they have to withstand the strains of the stripping process. When stripping forms, great care must be taken not to rake the form by prying on one end. This will cause opening of the panel joints and allow concrete and debris to distort the face of the form. Tag lines ensure effective control of the form when it is being moved. The main reason why tag lines are required is that the crane operator has no control over the form spinning. This is the result of sudden wind gusts catching the waylared side of the form, and could happen if no tag line were used. Flying of gang forms should not be attempted when winds are in excess of 50 kilometers per hour. Orderly stacking of forms in the correct sequence for reuse makes for increased efficiency. Haphazard storage of forms increases the chance of twisting and damage to the sheathing. Crane cables must be securely attached to solidly constructed lifting points. If rebar work holds up the efficient and speedy reuse of forms, using larger forms would result in them lying idle, waiting for other work to be completed. Even though very large forms might be useful for some applications, they will not be efficient if the design of the building calls for relatively small sections of work. Gang forms must be very rigid and stable. The limitations of available stock materials often restrict the effective size of the forms. In summary, then, efficient use of gang forms depends on these factors. A minimum requirement for ties, because their installation is time-consuming. They must be strong enough to withstand the pressure of concrete and durable enough to withstand heavy use. Easy connecting devices to allow for speedy ganging of forms and saving of valuable crane time. Gang forms must be adaptable to loose forms where these are required by building design. Easy anchoring to existing surfaces or reattachment to prior concrete placements. Flexibility of use in accepting attachments such as sleeves, bulkheads, box outs, and rough bucks. Tight joints between panels to reduce loss of cement paste. This joint, which was properly aligned, produced an excellent finish. On the other hand, this joint, was not well aligned and has resulted in poor architectural finish and a weakened structure. Gang forming is an effective way of reducing the amount of labor required when walls are typical and similar in design. Future developments will probably involve lightweight components.